Cartoon become our bench vise assembly project. This is our bench vise. In this bench vise, we have fixed jaw, movable jaw. We have serrated plates. These plates, we are putting them to protect our vise. We have here a shaft or spindle. Okay. Our movable block is fixed to our movable jaw with 4 screws. Our shaft will be fixed with this plate, okay, on the fixed jaw. So let's start building the parts. We start with fixed jaw. And here, as we can see, we will start with the front view of it. We'll draw 2 rectangles. Okay, the height is 160, here 70, and all of it is 360. So let's start. We go to new metric AOB part. We select 2D sketch, home, and let us take this plane and draw 2 rectangles. This is the first one, this is the second one from here up. The length is 360, as we said. We give it 360. Double click the wheel to zoom. These 2 pieces, 160 from here to here, or first 160. And this one is 70 and this one is 70. We give it equal constraint, this one to this one, in order to give 1 dimension. And give it a 70 here or there, doesn't matter. Where to fix our fixed jaw? Let's go there and see. I prefer to fix it on this hole. This one is 120 from the end. Okay, here is 70. Can you see 70? And this one is 70. So let us fix it here. Give it 120 from there. Okay, and dimension from here to the 0 point is 120. And we'll fix our base of my jaw on the 0 point. Finish. Extrude all from both sides. It is how much? 220. Okay, let's give it 220. 220. Hit OK. And we'll hit save. This is fixed jaw. Now we'll create the end of it. As we can see, the end is 60 from up, and from here to here is 70, and the width is 240. So go back here, take the XZ plane, and create a sketch. In project geometry, this one, and create a rectangle again. This rectangle height is 60, and this dimension is 70. Finish, and we'll extrude it from both sides to 140. We'll hit save. Let's go to continue. We create our main solid, as we can see it. Now we'll make cuttings in it. First cut, we have here 80, but we have hidden line down. this hidden line, this 80, it comes, as we can see, to here, from here there, from here there. What is it in the section? This is the section DD, and we can see this is the 80. Okay, and down we have 116. The height of 116 is 10, the same height as holes. Okay, so 116, while height 10, it comes here. Okay, let's go back to our, take the XZ again. Here's the XZ. Project geometry for this one. F7 to slide. And draw a rectangle again. Rectangle from here. Okay. We'll not give dimension, we'll give constraints. So we'll use collinear constraint. They are the same as this one, 360. Da? And the height is 10. This one is, this is the 10. It's collinear to this one. Finish sketch. And extrude it from both sides again to 116, 116. Cut. Hit OK. So this is my cut. We'll cut the 80 now. Okay. Then I can come here if you wish. Okay. Project geometry. This one. Okay, create a rectangle. F7 and F7. And you can create a rectangle. Okay. Collinear, it's to the end left. And collinear, this one to this one. Okay. And we'll put it on the middle. The width is 80, huh? The width is 80, 80. 80. And we'll put it at the middle using constant constraint, the middle of this one, the middle of this one. Hit finish, and we cut it through. Cut and through. Other than that one. Okay. Okay, so this is the way that our movable block will move on. Hit save. Next, we have a cut here. If you want to go here and see, we can see that our cut is 58 from here, okay, and 30 from here. The distance is 12, but if we are looking on the front view, we can see the hidden lines here. It comes all through, but here we have 12. So watch this. Let's go and see in our 3D parts. Can you see? We have to have this. This piece is putting to fix my movable jaw. It's going back. Will you stop by here in order not to go back? How to do this? It's easy. We go to XZ plane. Here's XZ plane, and we hit sketch. Okay. F7. Project geometry. This project. This one. By F7. And here we'll draw a line from up down. Here I'll draw a rectangle. Rectangle is equal 12, 12. Here, this one. And give it 12. 12. I'll trim. Give it dimension from here to here. It's 30, no? What is it? Go back to our from here to here, it's 20. Height 12, we already gave it. It will be 58 automatically. We'll give it 30. By 30. So this is the cut that we want to do. Finish. Extrude. Okay. Cut. from both sides to be the same dimension as this one, 80. So this is my stopping step only one. Okay, save. Now we almost ready. Let us draw hole fillets. Fillet. The big fillet, do it first. Okay. Then the 31st. Then all other fillets are 15. Then we'll draw this one first in order to have it right. 30. This edge. Here, okay. Now fill it again 15. All other fillets. Where is the fillets? We have fillet here. We have fillet here. Okay. This edge. And here, okay. Save. For fixing our jaw on the bench vice lamp, we have grooves here. How to do these grooves? We'll look. Then these grooves are looking like this. Okay. The fillet is R10. The height is 40. They are coming on the same hidden line. They are coming on the edge 10 millimeter up. They are coming 10 millimeter up. Okay. What's the shape? The shape is in the top view. It's a circle. As we have seen, we are seeing half circle here, which means that the center of this circle is on the edge. Okay, so we'll go back here. Where's my 10? We are 10 from here, so I'll create sketch on the 10 here. Okay. Project geometry. This edge. For what? F7. To draw a circle on this edge. I need half of it. I'll give it R50. And it will be 120 from here. We have here 120 now, so we can take horizontally or vertically, I don't know. Okay, this one with this one. Finish. The cut we said on 40, the height of the cut, then it's cut 40. Here, okay. Let us give it fillet by 10. Height 10. This one. This one. Here, okay. And this is our cut. Of course, we want to fix our jaw, so we have a hole here. Just see that the hole center, where is it? This is my hole center. And the center will be on the 120 from here, okay? And how much the distance from here there, we'll go to the section and we can see it 23. So it's 23 there and 120 here. Let's go back to our Chisna and create a hole, okay? And this hole is how much the diameter? We didn't know. Where is the diameter of my hole? Here is the diameter of my hole, 16. So we'll have a bolt or screw 16 diameter. Okay, let's go back here and give it 16. It's true, of course. 16. Okay. So where is it? It's here. And the distance from here there, we said how much? 23, da? 23. Okay, let's go back and give it 23. And the distance, the other distance is from the back, now. It is 120. This is my hole. The groove is ready. We need 4 of them. The other one here, you can't create mirror. Because if you take mirror, okay, of these and the plane that you will mirror, it's on 120. So you have to do an offset plane from here, okay, and calculate the distance in order to have it on the middle. Other way of doing this, we will go for rectangular pattern. we'll take the cut, the fillet, and the hole. Direction, we'll click on the edge. We need two of them, and the distance of it is 120 between them. Hit OK. Now we can mirror the rectangular pattern. The mirror plane as XZ. So XZ, this is the XZ, hit OK. And we have the four cuts. Next, we cut for the serrated plate here. Project geometry, and we'll draw a line. Then this one with this one, okay. And the distance is from here to there, it's 335. Go back and give it 35. 35. Finish. Extrude. Okay. And we'll cut it by, let's see, what's the cut here? Cut by 4. It's cut by 4. Give it 4 by 4. Okay. Save. Now we'll start with holes. Okay, we have two holes from here and two holes from here. Let us see the big one. The big one is here. It's 29 H8. 29 H8. Where is it? It's in the center of this one. In the center. I give no dimension for the center line of this one. It's in the center. This one is the other one. When you are creating cut, this one is out, and we are seeing the small one. It's in the center too, and it's 20. Okay, so well, how can we do it? Let us see. We have 60. The height is 60, and the width is 140. Let us dig a hole. A hole. If I wanted, it's 28, 29 or 28, I think. Pick it out. 29, sorry. 29. This is 29. Okay, from where? If I want to make it through, I'll put it here. Okay, it's in the middle, which means the distance from here, sorry, in the middle, we need the up and down. 29, height 29, here. Okay, the distance for the height, we didn't take the height, take it from here. Okay, the height is 60 by 2. And the width, 140 by 2. Now it's in the middle. Hit OK. Save. They are the same center with the hole that's here. So I'll simply hit sketch on this one, project the hole, finish sketch. We are having a center. I'll click hole on this center, and this hole will be 20. We forget the tolerance, 20. Okay, the tolerance is H8. Okay, okay, and H8. Here, okay. Okay. The other one, where is it? This one, double click, and we'll give it a tolerance. Again, tolerance. Okay, and H8. Here, okay. Here, okay. Save. Now we'll go for holes for the tabbed holes that will fix the serrated plate here and the plate that fixes the shaft here. We have two holes here. Where are they? Let us see. Here we have two holes, M6 by 1. The center dimension is 1740. And what's the hole? Here is our hole. It's 12. The thread is 12. The deep depth of the thread, of the length of the thread. and the hole is 17. Then M6 by 1, let's go back. Here, hole, tab, isometric profile, M16, 6, sorry, 6. There is 6 by 1, okay. And let's go down. The distance is 12 and 17. Let's check 12 and 17. Okay. Where are they? They are 17 and 40. 17 and 40. Okay. Let's put it here. Okay. From here, it's 40. And from up is 17. But let's see. Where is it? Mm-hmm. Okay. Are we ready? Yes. Apply in order to do it here too. From here to 40. Don't click anything, but give the distances, and here 17. Okay. And this is my hole. Now we have 4 holes here to fix the plate. For these holes, I'll draw points. Okay, 1, 2, 3, 4. Let me constrain these points horizontally and vertically. So I click the constraint, and this is vertically this one with this one, and this one with this one. Horizontally, this one with this one, and this one with this one. So I make them horizontally and vertically constrained. Now I'll give them dimension. The dimension between them is 90. Okay, from here to here is 40. From up, it's 10. Okay, 9040 between. Let's go. The dimension 90 from here to here is 90. And 40 from here to there. From up to here, it's 10. They're in the middle. How can we put this in the middle? In order to do so, we will use symmetric constraint. Symmetric constraint. How to do it? To create it, we have to have a symmetric line. The symmetric line is the z-axis. So I'll project the z-axis as z-axis and give it symmetry. With symmetry, this one and this one. The symmetric line is this. They are now, the 90 is divided by 2. The 90 is divided by 2. Other people will give it dimension from here to here is 90 by 2. The same. Okay, but we prefer to use constraint. Finish. Again, isometric profile, but let us see the parameters of this hole. Where's this hole? It's M508. The distance is 1822. M508, 1822. Again, 2 holes. Okay, isometric profile M5 by 18. Distances, how much we said? We said 18 and 22. The thread is 18. Oh my God. And this one is 22, the hole. Oh my God. 22. Already our holes are digged because we have center points for these holes. Here, okay. Our part is finished, so give it material S steel mild and give it a color red. Hit save. See it in real. This is realistic, and you can see that this is our part is ready. Oh, save. What similar parts do we have? Oh, sorry. The serrated plate, as you can see, we can take a copy. Okay, from here, it's the same. So I'll go back here. Where's the serrated plate here? And give it 10 millimeter thickness. I'll go back to my part, click here, sketch, and project. Okay, finish. The sketch, I'll use it for serrated plate. I'll hit copy. I'll take its visibility and go back new part. اوكي وناخذ ايش الواي زي and hit paste. This is my sketch. I'll fix it here. How to fix it here? So I'll take a point at the middle in order to rotate. I'll rotate all of this one. Okay, this one. The point of rotation is this, and by 90 degrees, the 180, 180. Head is done, and I'll move this one. Okay, من وين نشيله? The base point is here. I'll put as a 0 point. This point we don't need, we can delete it. Hit finish and extrude all of it with hold. And the other side by 10 here, okay. It's safe. And this one is serrated plate. How to create holes? I'll use the sketch again. In order to use any sketch again, hit the sketch, right click and hit share. It's highlighted again. What is how much the holes and what's the kind of these holes? Let's see. Then we have small countersink hole 6 and 13 by 90. So I'll go here, countersink. Here's countersink. Okay, here's 13 by 90 and 6. Where's my holes? This is the center of my hole, 1 and 2. If you, as you can see, we put a point here. Okay, either delete it before or hit Control in order to undo the hole. Then Control and hit the point, or delete it when you finish moving and rotating. Hit OK. So this is my countersink. I don't need the sketch again. Right click, hit it, visibility. So this is my countersink hole. Comes like this. Why? Yeah. What axis do we take? Doesn't matter. Okay. Let's fix it. This is my what? خلي هذا الفرونت. This is my front view. And this is my home. Here or there. Keep it there. And this is my home. My front view. Okay. Save. Steel mile. Our part is ready. But we are using a vise. And the vise is designed to squeeze, let us see, or fix parts between these two jaws. Okay. Here it's smooth. So when we put, for example, a pipe or any part between those, it can be slipping. In order to do so, we have to create a knurling. Okay, cuts on this face only. How to create a knurling? Knurling, we have two types of knurling: straight knurling or 45 diamond, we call it. Let us create diamond knurling here. On this, we'll create a sketch. I'll hit a line from here, anywhere. Okay, I'll offset this line. Trim 1, 0. It trimmed all of it because we didn't project the face. Project geometry, all the face. In order to have edges for trimming them. 1. And this one we don't need it here. But okay. Let us create the. No, let's give it 1 millimeter linear dimension. Horizontal, sorry. On, and then from this one to this one, and 1 millimeter, enough for us. Okay, and the angle is, as we said, it's diamond for 45 degrees. We'll hit finish. Okay, and we'll go to this one and cut. I'll just create another one in the same sketch. In the same sketch, let's create 2 of them. I'll take another one. I'll hit a line, same way. Offset this line. Okay, diamond trim first. High trim, high trim. Okay, the dimension is 1. It's the same. But in the opposite direction, huh? High 1. I'll just give it this one in order to have, if we want to change it, we can change it. Okay, the angle from here, there, 45 degrees. Okay, and we'll fix it in the middle. So use a constant constraint. Okay, take the middle of this one. Where is it? To the middle of this one. As we are creating a cross. Finish. Okay. Let's create an extrude cut. Okay. Okay. This one. Oh. Cancel again. We hit inside. Inside this one. Okay. This one. This one. This one. And this one. So. What takes outside? Okay. Control. Oh. What's going on? Something wrong goes on here. Again, extrude. Okay, this one. Cut through. The cut is 1 millimeter enough for us. 1. Okay, and this one, then, and this one, and this one. Here, okay. Why, okay. So I create cut by 1 millimeter inside. How to repeat these cuts? I'll go for rectangular pattern. I'll take this one. I'll hit on the direction on the line here. Okay, we need, I don't know, the distance between them, let us give it 3 millimeter. And I wanted to cover all the I-60. Okay, let us mid-plane give it. It's not covered all the plate. 80, note still, give it 100. Okay, hit okay. Give it time to calculate all these cuts. It's too much cuts here. Don't hit anything. We give it a time to finish. And this is my knurling. This is my knurling, as you can see. Okay? Diamond knurling, we call it. Diamond knurling. And we'll hit save. Let us stop our recording in order not to be boring, and we'll continue later.